Okay, folks, we're going to get started here shortly. Oh, there we go. Our next speaker is coming up here, which is Jakub Olesinski. I'll let him give a bit of a background on himself. As I've said, I think prior to the break, Jakub is an ecosystem forester with the government of the Northwest Territories, and he's going to give a bit of a talk today on monitoring climate change and the impact on forests. So Jakub, if you're good, I'm going to turn off my camera and mic, and I'll let you start sharing, and we'll turn her over to you.
Thank you very much, Hudson. Hello, everybody. My name is Jakub Olesinski. I am an ecosystem forester with the government of the Northwest Territories, Environment and Natural Resources in Hay River. And today I will be talking to you about some monitoring techniques and methods and overview of our monitoring of forest, and with focus on climate change impacts. And so let's jump in. I will be talking about what climate change means in the Northwest Territories and how it looks like. We'll look at some numbers, show you two graphs of how the temperature trends looked like over the last century for two quite extreme locations in the south and in the north of the Northwest Territories, just to give you a bit of a picture of what climate change means here and how it's been looking so far. Then I will talk briefly about how we monitor for climate change and how what kind of methods we try to employ to capture the changes that we see on the landscape. And again, then I will talk about what we actually see on the landscape. So I'll give you some examples of major impacts that we are seeing that we think are related to climate change. And finally, I'll try to answer the question, are the northern forests resilient to changing climate? And so starting with those two graphs that I mentioned, the first slide will be showing mean annual air temperature for two locations in the Northwest Territories. The first one is Hay River, located just north of 60 degrees latitude, and the southern shores of the Great Slave Lake. And the other is Inuvik, which is at 68 degrees latitude, and the north, close to the continental coast of the Northwest Territories, the Beaufort Sea. And you can see that there's two different graphs. Inuvik has a range of temperatures recorded. This graph is showing mean annual temperature trends for the last century for Hay River, and for about half century for Inuvik, because that's when the record started there. And you can see that Inuvik has a larger increase within the last half century. It's almost 7 degrees increase since the record started there, while in Hay River, mean annual temperature has been increasing slower, but it is still a significant increase of 3 degrees per century. So there are quite big differences between those two locations, and there is a whole range of conditions changing within those two, between those two locations. It's a very large area we're talking here about. So this is mean annual temperature, and if we look at the next slide, this is showing the winter or January temperature trends. So basically here, this is a different scale, so the slopes are slightly different from the previous slide. You can see that winter or January warming in Inuvik is about double of the annual warming, and it's almost it's pretty much 12 degrees recorded per century, or of that half century that we see here, while in Hay River it's 6 degrees. So the message here from those two slides is that there is more warming as you go north, and there is more warming in winter. So it's winter warming really that makes the whole of a difference here. It's also worth mentioning that Inuvik is warming about 4 times the global rate, which is about this is simply just a rapid rate of warming that we've been observing in this location there. So what it means for the northern forest? Well, some of the changes that we expect as climate change progresses include the changes in disturbance regimes. We're talking here about the northern boreal forest, which is disturbance-driven ecosystem. There are disturbances, they have been here for the centuries or millennia, and they will be occurring. However, the regimes that we've been observing or that have been here for millennia will be changing. And what kind of changes we can expect? Well, we were told that increased fire intensity and frequency and distribution may be likely, and then increased forest pest activity will be likely. So that includes range expansions of pests that we already have here, but maybe also more invasive alien species that have not been here before. Also, the projections talk about increased flooding or changes in hydrology, and that is related to permafrost thawing. And here is probably a good moment to mention that this is one of the greatest differences in the rest of the Canada that we're dealing with here, although the south of the Canada is the permafrost, and how forest ecosystems will change as permafrost is thawing. I'll have a chance to talk about it a little bit later in my presentations. So let's just talk about monitoring right now. I mean, this is a large area we talk about here, about 80 million hectares of forested land. How do you monitor area like this with limited resources that we have and limited human resources that we have? Well, you have to prioritize, and we're using a few tools that we have here to capture as much as we can in a short window of time that we can actually see a lot of changes. So we use forest health surveys as our main forest condition survey. And there's a few reasons for that. First is that forest health surveys are done on the annual basis. So we have a good way of updating our databases, and we see the change on an annual basis. And forest health conditions are often driven by climate. Therefore, consistent forest health monitoring can be used as an sort of an early warning system for changing issues. And these emerging issues need to be really investigated further and tracked for several years to properly identify those impacts of a changing climate. So what we found really is that establishing baseline information is the key. And is essential, and Northwest Territories is quite unique. It has some good baseline information on certain issues, such as, for example, spruce budward defoliation, because it was tracked here since 1950s by Forest Insect and Disease Survey. But we don't have good baseline information for other issues that are occurring. For example, many of the abiotic disturbances that we are seeing more and more on the landscape. So our forest health surveys are done on the priority areas, and you can see on that map that the highlighted areas are our forest survey routes, and they are concentrated along the main river systems, along the main hill slopes, because that's where mature spruce dominated forest occur in the Northwest Territories, and that's where we see most of the forest health related issues. And wherever we can, we expand those areas, we expand those surveys into other areas. If we notice something is going on in an area adjacent to our flight paths, we would explore it during our survey. So essentially, this is a very good tool for us to investigate these issues. And we try to have at least one major pan-territorial survey where we cover as much as we can. But also, if need be, we have additional surveys in June to capture aspen defoliators, for example, and things that may appear before summer. Since 2015, we noticed that there is a really big gap in our data system, and it's related to abiotic disturbance that we've started to see more and more prominent on the landscape. So we started to record it about that time. And that includes mortality from drought and some wind and hail and snow damage that we could discern, mortality from flooding and high water tables, permafrost-related damage, red belting, and species declines such as aspen decline and black spruce. So talking about monitoring methods, I mentioned here aerial detection as one of the most important tools for us, but we also employ other methods to try to capture issues that are emerging, and ground surveys are the best tool for that. We have a very scarce network of road in the Northwest Territories. Therefore, we use them to our best ability. And this is really along the ground, along the road survey where we capture and we noticed new things where we can actually investigate things from the close-up, things that we don't notice from the air, things that would go amiss in our other survey methodology we would capture in our ground surveys, at least where we can. Pheromone trapping is used for mostly detection of absence, presence, invasive or alien species, or in our case, we use it for mountain pine beetle monitoring. Public reports are very helpful wherever we cannot get to. There is always a community nearby and the residents are capturing interesting finds and report back to us, and that way we also can be aware of issues that are going on that we would normally not be capturing. PSPs and remote sensing are also tools that we try to incorporate more and more, and I'll be showing some examples of those pilot studies that we do. Long-term research is done by our partners, and we have a great collaboration with Canadian Forest Service, Northern Forestry Center. They've been here for many years and are doing amazing research for us, which we can use in our management decisions. We have a partnership with Wilfrid Laurier University, which we also are very we're using very much the research that these guys are producing. As well as tools like ecological land classification that was created specifically for the Northwest Territories, and this was created in early 2000s, so it has information relevant to that period of time when we can compare with current conditions, some of that information captured in this land ecological classification. So let's talk about some impacts, what we actually see on the landscapes. And so perhaps the most significant impact that I can think of a warming climate that we have been observing over the last 2 decades is the northern shift of spruce budworm, which is the native pest in the Northwest Territories. And it's also the most significant, most serious pest. The culmination, so we can see that this really, the northern shift has been occurring since early 2000s. And the culmination of this shift was the outbreak that we observed in the Mackenzie Delta in 2015. That was 100,000 hectares of defoliation in this extremely north environment. The outbreak collapsed and the following year, but the fact that it occurred there is a big sign that conditions allowed for build-up population of the population like that. Another significant outbreak of native pests that moved from the south were the forest ant caterpillar outbreak in 2017 in the South Slave. We have also observed advancement of willow defoliators, such as willow blotchleaf miner, defoliating willow in our northern, beyond the Arctic Circle, basically, in almost touching the Mackenzie Delta as well. Gray willow leaf beetle, another example. Increased activity of invasive species. So we have increased activity of amber-marked birch leaf miner in the Northwest Territories, which is affecting our birch. But also new pests and diseases. So for example, false hemlock looper defoliation was observed in Fort Smith in 2013 on spruce and pine, with a total of 100 hectares. It is a species that can be found across Canada, but has not been recorded in the Northwest Territories before. So those are some of the examples of the biotic disturbances that we started seeing in a quite recent time. Other impacts are those related, not directly related to biotic agents. We're talking here about the flooding. This has been one of the most serious and major issues that we've been seeing on the landscape. The photos here show the forest north of Port Providence, which has undergone significant mortality in recent years due to large-scale flooding and rising water tables. And those disturbances are thought to be associated from indirect drainage of melted permafrost water from surrounding large-scale forest wildfires that occurred in 2014 and early. Actually, most of that is probably from the 1995 fire on the Horn Plateau, as shown on the map here. And In 2017, our Forest Health Survey detected approximately 117,000 hectares of widespread tree mortality, where flooding was evident. However, it was really unclear whether this tree mortality occurred in recent years, what was the rate of that mortality, and was it a result of a long-term forest decline in this region. So we asked our colleagues at CFS to help us with answering some of those questions. And here is the example of the remote sensing study conducted by the CFS scientists Rob Skaken and Guillermo Castilla team. And they did exploratory satellite-based assessment in the area that I showed on the previous slide, north of Fort Providence. So they looked at changes in biomass and tree cover in this flooded area, and the preliminary results show that 23% reduction in biomass was observed in just over 10 years, and a 48% increase of areas that were less than 25% of tree cover was also observed just over the 10 years. And I will not really dive into technical aspects of this study. I will leave it to experts. If you'd like to learn more about this preliminary study, you can contact Rob Skaken at Canadian Forest Service, and he'll be happy to provide you with some more background info of that. But that's just an example. You know, this study pretty much took us back to 2005. That was the limit of the data available. But it showed us the rate of decline in this area associated with this flooding. So we do need more of this kind of studies to help us explain some of the issues that we are seeing. Some other projects related to remote sensing that we have are looking at tasseled cap products, and we're not quite ready to present on those yet, but we try to employ as much of remote sensing to help us explain some of those changes. Another very specific to the north example of what can climate change do to our forest is the permafrost thaw. So these images show direct impacts of thawing permafrost on the landscape. The disturbance in Richardson Mountains and near Fort Simpson is called a thaw slump. The slumps develop on slopes and usually occur along the shorelines of lakes, rivers, and coastlines. And thaw slumps are common permafrost mass wasting features, and they consist of a head wall made predominantly of ice and muddy slump floor. Another direct result of permafrost thaw in forested areas is a phenomenon called the drunken forest. So that's the photo shown on the bottom left there. And in areas where the permafrost temperature is near the melting point, or climate variations or loss of surface vegetation from fire or flooding can thaw the upper extents of the permafrost, creating a thermokarst, which is a scientific name for a ground slump caused by melting permafrost. In the thermokarst undermines the shallow root bed of these trees, causing them to lean or fall in random directions. That's why it's called drunken, probably. Thermokarst lakes, this is another feature that is quite characteristic, and those lakes are surrounded by a ring of drunken trees leaning towards the lake, which makes these land features quite easily identify. Permafrost is a very complex issue that we deal with. We still don't know much about it, and that's why we collaborate with our research partners from Wilfrid Laurier University. They have been studying permafrost changes in a study site called Scotty Creek Research Station, which is located south of Fort Simpson, and they operated since the 1990s, so they have a pretty good record of changes that have been occurring there since the time they set it up. It's located in a wetland-dominated terrain underlain by discontinuous permafrost. And discontinuous permafrost means that the permafrost is only underlain in certain areas. It's not continuously underlaying all types of landscapes just selected. In this case, permafrost is located in areas where under peat plateaus, and they're usually covered by black spruce. So here some results show that proportion of 1 square kilometer area underlain by permafrost decreased from 55 to 43% between 1970 and 2008. And you can see that on this diagram here that the permafrost width shrunk from 33 meters to just almost 18 meters only within 9 years. So it's pretty rapid change that we're observing there. So our questions are, what happens after the permafrost thaws? What kind of ecological succession pathway we can expect in these areas? Those are all questions that we still need answers for, and the research is ongoing. Other climate-related impacts that we also monitor for is drought effects, red belting, some increased mortality from spruce budworm that has been settling in, but also some intense wind events. That's seems to be increasing in intensity and over the last years, or maybe we simply have not paid attention in the past. So that's another question here about how important the baseline information really is to be able to properly assess climate change impacts. If you don't know what's normal, you cannot know what's not abnormal. So that's one of the biggest challenges I think that we have is to have this baseline information for a lot of issues that we are seeing on the landscape. Another impact that I wanted to mention here is aspen decline that's been ongoing in the southern southwestern Northwest Territories, mostly in the Dachau region. The decline is occurring throughout the range, really, of aspen, but appears more severe in those locations in the west. And much of the decline is occurring in mature aspen forests, but the dieback can also be seen in younger aspen through the Dachau and parts of the South Slave. It is suspected that it is occurring primarily due to some severe droughts that are affecting upland areas, and those droughts that we talk about here are the 1995 drought and 2014-15 drought. But also not only droughts, but also high water tables that have been really prominent in the last few years in some lowland areas. On top of that, we have outbreak of forest ant caterpillar in 1995-98, and there is a 20-year really ongoing outbreak of aspen serpentine leaf miner that also probably has an effect on the aspen condition. So it's a bag of mixed effects really that's been happening. And the picture wouldn't be really complete without mentioning our most important disturbance agent, which is wildfire. And I know we have a presentation later on fires, so I will not talk too much about it, but it's quite remarkable here that just over the last decade, we saw two extremes of the spectrum. 2014 was the most active fire season on record, while 2018 was one of the least active seasons on record. And perhaps even more remarkable is the fact that 4 years since 2000 have ranked amongst the top 15 slowest of all time in terms of ignition, despite climate change projections of increased burned area severity and frequency of fires. Our data do not show the increasing trend, but rather a very high variability over the last couple of decades, making fire seasons more unpredictable. So that's all I'm going to say about fires, knowing that there's a presentations on fires coming. It's just another sign that climate change is more about extremes. So we have a great example of that here in the north when it comes to fires. So finally, are the northern forests resilient to changing climate? Well, northern boreal forest is really a complex ecological system, and there are many things that are occurring in the north and that we currently do not really recognize as climate change related issues. There are issues that we see every year that have no obvious culprits. They have no obvious damaging agents, but there's definitely something weird going on. For example, we noticed last year strange reddening of needles on pines, and without very obvious primary or secondary pests. And the issue probably is related to some kind of an environmental change, but we're not able to really say what it's causing it. So it's a complex system. We have things like permafrost, which adds a very high uncertainty and makes things unpredictable. It's possible, that the variability in fire seasons is partly due to what's going on with permafrost, and we see a lot of moisture in the southern parts of the territory for the last 5 years. There are a lot of high water table issues, flooding. So it's not really a straight forward answer, and projecting future outcomes is really challenging because there are a lot of unknowns, and I say. But the answer probably is to be able to monitor consistently and develop baseline information, and I cannot stress that more. Again, the baseline information for us means pretty much learning of what is a normal situation in this disturbance-driven ecosystem, and what is not normal. What can we expect in the future? So that is probably not the answer to these questions. I will probably not be able to answer it right now, but asking it, I was trying to make a point that we need consistent monitoring, and we do need solid baseline information to be able to answer some of those questions. So I would like to acknowledge several people here, mostly from the Canadian Forest Service Northern Forestry Center. When I say we discovered this and we tested this and we flew the survey, I mean Roger Brett, who is a forest health specialist from the Canadian Forest Service, and he's been a great help in our monitoring and great resource. I also have been in contact quite often with Greg Paul and Todd Ramsfield for help in IDing and some diagnostics. And we also been collaborating quite intensely with Jason Edwards and his adaptation team. And we are actually undergoing a vulnerability assessment, which is a separate topic of discussion. So that's been a pretty interesting journey for us here, journey of discovery mostly, and education. And I also want to acknowledge academic partners that we are with. Wilfrid Laurier University, University of Alberta, and University of Lethbridge are our main contributors and help. So that is all that I have. And I also wanted to mention that we do publish our forest health reports, which are quite technical. On top of that, we do try to publish annual forest health newsletters, which are more kind of plain language summaries of what we see each year, and they are available on in our website if anybody is interested. I'm also open to any questions. If anybody has any follow-up questions, they can contact me, and I'll be happy to answer.
That's great. Thanks, Jacob. That was an amazing presentation.
Thank you.
I guess, yeah, we'll open it up for some questions. We do have some time here. We had an accolade from Marty Alexander. Excellent presentation. Thanks, Marty. Okay, I'm not seeing any questions on either of the chat windows. So what I'll do here then is I think we'll stop the presentation, and then we will start up again here for our next presenter, which will be Dave Stevenson at 1:15. Okay, folks, have a good break. We'll see you guys here at 1:15.